Some of the cheapest e-bikes actually cost the most to own. Today, we're breaking down the 10 components that make buyers regret their purchase, ranked by real owner complaints across forums and repair data. The surprises here are brutal. And the number one issue? It's something manufacturers deliberately design into budget bikes to lock you into their ecosystem. Ignore this and you might end up with a $1,000 paperweight when the first major component fails. The worst part? Most of these problems won't show up during your test ride or even the first month of ownership. So here are the 10 things that separate an e-bike you'll still enjoy riding next year from one you'll be trying to unload on Craigslist for half what you paid. Number 10. Plastic display mounts and cable clips. Let's start with something that won't stop your bike from working, but will absolutely annoy you every single ride. Budget e-bikes use ABS plastic for display mounts and cable management clips. 3 months of sun exposure and vibration, that plastic becomes brittle. One pothole and your display mount cracks in 2 places. By month 6, you're holding your display in place with zip ties because the mount completely failed. Quality bikes use aluminum or reinforced nylon for these critical mounting points. Budget bikes use injection molded plastic that costs them maybe $2 but fails predictably. One electric bike review forum user documented his electric XP display mount cracking within 6 months. 3 separate stress fractures from normal riding on paved roads. The replacement? Electric wanted $40 for another plastic mount that'll do the same thing. He bought an aftermarket aluminum mount for $25, which should have been included from the factory. The cable clips fail the same way. They crack. Your brake cables start rubbing against the frame, creating annoying clicking sounds every pedal stroke, and eventually the housing wears through from the friction. Now you're looking at cable replacement because a $2 plastic clip failed. Minor issue individually. Death by 1,000 cuts when it's happening to 5 different plastic components simultaneously. Add up the replacement parts and labor, and you're easily looking at $70 to $100 fixing problems that shouldn't exist on a $1,200 product. Number 9. Fake suspension forks that actually make riding worse. Here's where things get insulting. Those RST Gila, or generic spring forks on budget bikes, they're not really suspension. They're pogo sticks with massive stiction and zero damping. Calling them suspension is technically accurate in the same way calling a cardboard box a house is technically accurate. Real suspension has 2 jobs: compress to absorb impacts, then return smoothly without bouncing. That requires both a spring and a damper working together. Budget forks use a single spring with essentially zero damping mechanism. According to extensive MTBR forum discussions from actual owners, riders report having to preload these forks so stiff just to prevent bottoming out on moderate bumps that the fork barely compresses at all. One rider described forearm fatigue after just a 2-hour ride on relatively smooth trails because the fork was transmitting every crack and pebble straight through the handlebars instead of absorbing anything. The first month you don't notice because you're comparing it to no suspension at all. By month 3, you realize the fork is actively working against you. It adds 4 to 6 pounds of weight to the front end. It adds flex to the steering. It provides almost no actual shock absorption. The stiction, internal friction from cheap seals and bushings, means the fork doesn't respond to small bumps at all, only jarring impacts. Quality suspension from Suntour Mobi, RockShox, or Fox costs $400 and up, but it actually functions as intended. These RST units exist purely so manufacturers can advertise front suspension in the product description and charge $50 extra. Want to upgrade to something that actually works? You're looking at $300 to $600 for a proper air fork with real damping. That's a fork that should have been included at the price point in the first place if manufacturers weren't cutting corners. Number 8. Budget tires that wear like erasers and puncture like paper. Kenda and CST, Chengxin Tire, make both quality tires and absolute garbage. Unfortunately, budget e-bikes spec the garbage tier. The difference comes down to 3 factors: TPI, which is threads per inch in the casing, rubber compound quality, and puncture protection layers. Low TPI means thin, weak casing that flexes excessively and wears fast. Cheap rubber compound means reduced grip and accelerated tread wear. No puncture protection layer means you're patching tubes every other week. Compare that to Schwalbe Marathon Plus or Continental Contact tires designed for e-bike loads and speeds. Those can exceed 5,000 miles before needing replacement. They cost $40 to $80 per tire, about the same total cost as replacing cheap tires 3 times. Here's the math. Budget tire at $35 times 3 replacements over 2 years equals $105 plus 3 trips to the shop or 3 sessions of your time doing it yourself. One set of quality tires at $90 to $100 lasts the same period. You also avoided 3 flat tire incidents, the frustration of dealing with roadside repairs, and the risk of being stranded mid-commute. The budget tire trap perfectly illustrates false economy, spending more money in the long run to stay cheap in the short term. And that's before factoring in the value of your time and aggravation. Number 7. Mechanical disc brakes and the never-ending adjustment treadmill. Mechanical disc brakes aren't inherently terrible. High-end mechanical systems like Avid B, B7, or TRP Spire can perform quite well. But on budget e-bikes, mechanicals become a monthly maintenance ritual that never ends. The fundamental problem is cable stretch. Steel cables stretch under repeated load cycles. As they stretch, brake lever travel increases and stopping power decreases. Every 2 to 4 weeks with regular riding, you're back at your workbench adjusting cable tension to restore proper feel. Worse, most budget mechanical systems use single-sided actuation. Only one brake pad moves. The rotor has to physically flex sideways to contact the fixed pad, creating that mushy, wooden, inconsistent feel that riders complain about. According to Electrek's comprehensive brake comparison testing, hydraulic systems deliver 20 to 30% more stopping power with significantly less hand effort. The fluid transfer is more efficient than cable pull. Plus, hydraulics self-adjust automatically as pads wear, eliminating the maintenance cycle entirely. Want to upgrade to hydraulics after the fact? You're looking at $150 to $300 installed at a shop, or about $120 to $200 for a quality set plus your time if you're comfortable doing the work yourself. That's money you wouldn't need to spend if the bike was spec'd correctly from the factory. The savings from buying cheap just evaporated. Number 6. LCD displays that fear moisture. Despite waterproof ratings, that LCD display controlling your bike is rated IP65. Theoretically, waterproof and dustproof, right? Marketing says so. Reality disagrees. According to extensive electric bike review forum threads documenting failures, even Specialized, a premium brand with quality control standards, has documented LCD backlight failures on certain models after just 2 to 6 months of normal use. If Specialized struggles with display reliability, what's happening with no-name generic displays on budget builds from manufacturers with zero quality reputation to protect? The core issue is sealing quality and circuit board protection. Proper displays use precisely molded gaskets at every seam, sealed button membranes, conformal coating on circuit boards to resist moisture, and fully potted connectors. Cheap displays? One Reddit user who opened his failed unit 9 months into ownership found literally zero waterproofing, no conformal coating, no gasket material, just bare circuit board inside a plastic housing with visible gaps. The product description claimed IP65 weather resistance. The reality was moisture got in through the button membranes during the first rainstorm, through the connector during a bike wash, and through invisible seam gaps from humidity. Once moisture contacts the circuit board, you get flickering displays, dead backlights making the screen unreadable in anything but direct sunlight, phantom button presses, or complete failure requiring replacement. Replacement cost runs $50 to $150, depending on whether you can find a compatible aftermarket unit or must-buy OEM. But here's the truly predatory design choice. Many manufacturers use proprietary communication protocols between display and controller specifically to prevent generic aftermarket replacements from working. The connector might be standard, but the data protocol is custom. This forces you to pay inflated OEM prices when the inevitable failure occurs. Prices that include healthy profit margins since you have no alternatives. Your cheap bike just cost you another $100 to $150 for a component that should have been properly sealed from day one. Number 5. Kickstands that can't support e-bike weight. E-bikes weigh 50 to 70 pounds fully loaded, literally double what regular bicycles weigh at 25 to 35 pounds. Yet budget manufacturers install the exact same kickstands designed for regular bikes because they cost $3 less than proper e-bike rated stands. Physics doesn't care about their profit margins. These undersized kickstands fail in two predictable ways. First, the kickstand leg itself bends permanently within the first few weeks from supporting weight it wasn't designed for. Once bent, the bike leans at increasingly severe angles until it eventually tips over. Second, the mounting plate, usually thin stamped steel, cracks from repeated stress cycles. When the mounting plate fails, the kickstand detaches completely and your bike crashes to the ground. The solution? A proper center mount kickstand or dual leg kickstand specifically rated for e-bike weight costs $30 to $60. Greenfield, Pletcher, and BV make reliable options. Add it to your mental necessary upgrades list along with all the other components that should have been correct from the factory. The savings from buying cheap continue evaporating. Number 4, proprietary battery ecosystems in the replacement hostage situation. Now we're entering deal-breaker territory where seemingly minor decisions at purchase time destroy you years later. Proprietary battery systems don't hurt you when you buy the bike. They're invisible during test rides. They work perfectly fine for the entire warranty period. Then replacement time arrives and you discover you don't own an e-bike. You're leasing it from the manufacturer until they decide to stop supporting it. When your battery inevitably degrades and lithium-ion chemistry absolutely guarantees degradation over time, you're a captive customer. According to Leo Guarbike's comprehensive 2025 pricing analysis of replacement costs across brands, Bosch replacement batteries run $600 to $1,200 depending on capacity. Shimano runs similar pricing. Generic 48-volt batteries with equivalent watt-hour capacity and quality Samsung or LG cells, $300 to $500. But you literally cannot use them because Bosch requires encrypted communication handshakes between battery and motor controller. The cautionary tale: VanMoof's bankruptcy in 2023 left over 200,000 owners with bikes whose proprietary batteries they literally cannot replace at any price. The battery worked perfectly until it didn't. Then their $3,000 bikes became garage sculptures. That's the existential risk you accept with any fully proprietary system. You're dependent on that specific company continuing to manufacture that specific battery format indefinitely. When they stop, your bike becomes electronic waste, regardless of the mechanical condition. Number 3, controller failures. The controller is your e-bike's brain, the microprocessor-based component that connects battery to motor while managing throttle input, pedal assist sensor data, display communication, and safety cutoffs from brake sensors. It's doing complex, real-time calculations hundreds of times per second. When it fails, nothing works. The bike becomes completely inoperable, and on budget e-bikes with poor environmental sealing and inadequate thermal management, controller failures happen frequently enough that dedicated forum threads about them span hundreds of posts and thousands of replies. According to extensive documentation on electric bike review forums, controllers fail primarily from 2 causes: moisture infiltration, corroding circuit boards and solder joints, and thermal stress from inadequate heat dissipation during high-load operation. Budget controllers use minimal conformal coating, if any, rely on passive cooling without proper heat sinking, and feature connector sealing that's marginal at best. One documented specialized owner, again a premium brand, needed controller replacement within just 6 months of ownership. The diagnostic cost? $80. The replacement controller? $250. Labor to install and program it? Another $100. For a component you cannot see, cannot physically inspect for wear, and won't know is failing until your bike suddenly refuses to power on one morning. You're looking at $350 to $450 total to replace a component that costs manufacturers maybe $30 to $50. The compatibility trap deepens here. Controllers use manufacturer-specific connectors for every interface: battery, motor phase wires, hall sensors, throttle, pedal assist sensor, brake cutoffs, and display. There's no universal standard controller you can swap in. Attempting to retrofit a generic aftermarket controller requires rewiring potentially a dozen connections, possibly replacing the display and PAS sensor if communication protocols don't match, and praying the voltage and amperage specifications align properly or you'll damage the motor. Quality e-bikes use fully potted controllers with robust waterproof connectors rated for automotive environments. Budget bikes use whatever's cheapest and cross their fingers it survives the warranty period. Number 2, battery capacity degradation. Here's the fundamental lie built into every budget e-bike advertisement: 500 to 1,000 charge cycles before replacement. What manufacturers deliberately omit is that cycle count assumes ideal conditions that budget systems never provide. Optimal storage temperatures between 10 and 25 Celsius. Partial discharge cycles staying between 20 and 80% state of charge. Quality cell chemistry from reputable manufacturers like Samsung, LG, or Panasonic. And sophisticated BMS, battery management system, circuits that carefully balance individual cells and prevent stress conditions. Budget e-bike batteries provide exactly none of those things. According to detailed technical discussions on Endless Sphere from electrical engineers and battery specialists, budget e-bike batteries frequently use the absolute cheapest 18650 cells available, sometimes literally recycled cells harvested from used laptop batteries, sometimes fresh cells from bottom-tier Chinese manufacturers with zero quality reputation. These get paired with basic BMS systems that do minimal cell balancing, allow deeper discharge than optimal, permit charging to absolute maximum voltage, and provide no thermal management. The result? Rapid, dramatic capacity degradation. One meticulously documented case study tracked a budget battery losing 20% of original capacity within just 2 years and approximately 300 charge cycles, far below the advertised lifespan. A quality pack using Samsung 35E cells with proper BMS might lose only 10% capacity over that same period under identical usage patterns. Replacement time arrives sooner than expected. $400 to $800 for budget replacement batteries if you can even source a compatible one. $600 to $1,200 for proprietary systems where you have no choice. For a bike you originally paid $1,200 to $1,500 for. That's not a routine repair cost. That's nearly the price of buying a complete second bike. And you'll face this expense again in another 3 to 5 years because batteries fundamentally degrade regardless of quality. It's just a question of how fast. Number 1, zero local bike shop support. This is the hidden deal breaker that nobody discusses during the exciting purchase process, but becomes brutally apparent the first time something breaks. When a component fails on your budget direct-to-consumer e-bike, you discover you're completely on your own. No safety net, no local expertise, no convenient repair option. According to extensive, detailed forum discussions spanning years on Electric Bike Review with hundreds of documented experiences, local bike shops systematically refuse to work on direct-to-consumer e-bikes from brands like Rad Power, Juiced Bikes, and especially no-name Amazon or Alibaba brands. This isn't bike shop snobbery or gatekeeping. The reasons are entirely business practical and liability driven. First, shops cannot source proprietary replacement parts. Each budget brand uses custom battery connectors, unique controller pinouts, and brand-specific displays. When your controller fails, the shop cannot order a replacement from Quality Bike Products or any standard distributor. They'd need to contact the manufacturer directly, if that manufacturer even sells individual replacement components, which many don't. Second, shops don't have diagnostic equipment or technical documentation for dozens of different electrical systems. A Bosch diagnostic tool costs thousands of dollars but works on every Bosch system. A no-name controller from Alibaba? There's no diagnostic protocol at all. Third and most important, shops refuse to accept liability for electrical repairs on bikes with questionable safety certifications. This leaves exactly 3 options when electrical components fail. Option 1. Become a self-taught DIY mechanic. That requires investing in tools, spending hours researching on forums, developing electrical troubleshooting skills, accepting significant risk of making problems worse, and having tolerance for frustration when things inevitably don't go as planned. Option 2. Ship your entire bike back to the manufacturer for service. Assuming they're still in business, ask the 200,000 Van Moof owners how that option worked when the company declared bankruptcy. Shipping costs alone can exceed $150 each direction. Plus, you're without your bike for 2 to 6 weeks. Option 3, accept the bike is now electronic waste and buy something else. The real cost of a budget e-bike isn't the checkout price. It's the purchase price plus $500 to $1,500 in component upgrades, premature battery replacement, and repair frustrations distributed across the first 2 years of ownership. Sometimes that works out fine if you're mechanically inclined and enjoy tinkering. Often it means your great deal becomes worse value than buying quality components from day one. If you're comfortable with the reality that budget means trading upfront savings for later expenses and occasional significant frustration, these bikes can work. The issues we've covered aren't theoretical. They're documented patterns from thousands of real owner experiences. The question isn't whether these problems exist. The question is whether you'd rather address them proactively by spending more initially on quality components or reactively when things fail and you're desperately hunting for solutions. Speaking of spending money wisely versus wastefully, while you're thinking about what genuinely improves your riding experience versus what's pure marketing designed to separate you from your cash, check out our video breaking down 12 e-bike upgrades that are a complete waste of money. Link in description. Some of those must-have accessories dealers push. You'll wish you'd kept your cash and spent it on components that actually matter.